I'm Matt Land from Phpunit. Work downtown. I'm now in like a platforms kind of role, so I don't get to do much UI stuff. But I spent a lot of time in the last year modernizing some of the applications there that maybe weren't rolled out with the best practices in mind when they started. Just getting hard to maintain. You know, at some point you threw in a framework, got your application, your ZF1 application working, but then maybe we never updated the ZF application again after that, and obviously there's security issues with that. So we just kind of modernized a lot of different things. We had some growing issues with the number of developers we had. The processes that worked for 5 developers, 10 developers, where we all deployed at 3 o'clock every day, totally broke apart when you have like 30 developers trying to all deploy at once. So we've broken out and kind of gone to this continuous delivery thing. Let's see how we're going to advance. There we go. So where we're headed with this, I'm going to show an application here that has, this is like an actual application that's already set for CI. It's got a bunch of little extra files than you wouldn't normally see. You're probably familiar with like the vendor folder, or if you've composed in a library before, git ignore is pretty common for the stuff that you don't want to check in. We obviously don't check in anything that's in our vendor folder. If you have credentials that you're checking in your project, you want to skip those too. The auth.json is a special security token, because when we use GitHub, because we're using it in our CI server, we make so many requests per hour. We go over the anonymous usage limit, so we need the credential token linked to an actual account, which raises the limit, so we can pull down, whatever framework or library that we need from them many, many times an hour. The build.xml I'll get to a little later. That is our build process file. That's if you've done Java in the past. It's same as an XML markup language that lets you do a lot of different things. The composer configuration itself, we check in the lock file. That's how our server knows what to check out and build. The composer executable itself, we check into the projects. We let our build process even update to the latest versions of Composer every time it runs. So we never have to get that, your version of Composer is 60 days old message. We also have Css Assets that get built by Grunt. That also gets called as part of the build process. There's no manual steps where we have to update our CSS and check it in. The JUnit is an output file that's probably in the git ignore. It's because I ran the test locally. That's from PHPUnit. That's one of the output formats. The CI server speaks JUnit. It's a very common Java logging language for test cases, so that's why that's what we use, and that's why it shows up. Package.json, I think that's for probably some of the JavaScript bits. And we'll let it sleep. Okay. Okay, cool. Phpunit Xml file itself, if you're doing testing, you've probably written one of those because it makes it a lot easier to run your tests. Otherwise, it's a great recipe formula for setting up test suites and telling PHPUnit specifically how to run in your CI environment. We also have this post-prod deploy, which is how we actually inject our credentials. The way our deployment process works is we check in, and that's the last the developer touches the code. The staging and development environments will check the code out from source control, run all the scripts, but our actual deployment to production is an rsync of whatever was on the stage. So we don't do those processes once we've verified that they work and all the code checked out correctly. So we don't run tests in prod. We rsync everything over, but the last thing we have to do is inject the credentials that production uses. So that script says, on this server, I know where to get the credentials for that server, and I will pop them in as the last step. Results.json is another PHP output file. And then we have an additional CI folder that is cropped off at the top that has more targets, the ones that are related to testing, PHP mess detector, things like that, we put in this other folder. And then I'll get into the pre-deploy, post-deploy. But there's some steps that need to happen on different servers because in CI, your code doesn't all run in the same place. The tests run on a different server than you're actually testing. So some things need to happen in one place. Like Composer happens before we rsync the code out to the destination, but some things happen after that where we have to set up symlinks for the application. So,
I didn't actually plug it in. Right.
plug in. Oh, cool. Okay, so the whole terminology, I don't want to get hung up with it, but I do want to cover like what it is. So we have continuous integration, which is you're now using shared source code with other developers on your team. You probably have some level of test coverage. It may or may not be automated. Hopefully it is, but like that's where you want to work towards. And then we establish that testing contract. Like once you've got your test running, if the developer writes a feature and writes a test for it and checks it in, if someone else breaks that test, it's on the developer that broke the code. That is the testing contract. And that's a really nice thing to know that when you write a feature and tests exist, it's going to go out and live as long as your test keeps passing. So the next stage is like continuous delivery. This is, you know, it's a lot more steps to like get it all set up. You remove all the manual steps in the process. There's no longer anyone doing any manual commands. It's like you check in code, it goes to this server, it goes to that server, and then you deploy to production. But you're not doing very many manual steps. And then your environments need to be really close to the same thing as where you're going to deploy in production. You want it as close to production as possible. In our case, we use, for all our servers, they're kind of here and there. They don't last very long. But we'll bring up a server. We use a salt stack recipe to bring up a server. We bring up our other servers for dev environments the same way. So it's the same recipe. We'll bring up a server. We'll use it for a few days. If anything changes in configuration, we bring up a new box with a new configuration, deploy to that box, and then just kill the old one off. We never upgrade anymore. We don't migrate server to server. We just bring up a new one and change where the load balancer points. But we use that same recipe of every server is going to be identically configured across the board, so it's always the same. And no surprises with, it works in dev, but it doesn't work in production. So finally, the last thing is we have this concept of continuous deployment. We don't actually do this, but you can set this up so that your feature works and it gets passed off by QA. As soon as it passes tests, it just goes ahead and ships because you have high or a fair amount of code coverage, you have high confidence in your application, your stuff can just go out. And this is pretty neat as a concept, but we usually just write our features, check them in, and if they work, we just go ahead and kick off the deploy right then during business hours. But we don't let the robot do it. So this is kind of like summarizing that up into what the differences are, but that's just a background. Doesn't matter. That's not the point of getting to it. The point is to like get to these benefits in your own application, not meeting like some standard definition of it does this thing or that thing. It meets the definition of being, who cares? Like you just want to improve your application. I think that the process is really beneficial versus like the old, okay, at 3 o'clock we're going to FTP some stuff out and then we're going to test it again in production and hope it all works. And everyone's going to be stressed out because it might break and customers are going to be angry and everyone's going to be looking. That just, all that goes away. So there's also a degree of like, anybody is empowered, any of the developers on the team are empowered to send their feature out, assuming they pass their tests or they wrote some tests. It doesn't have to be like that one person who has the credentials can let the code go out. The other thing is that tacit knowledge, if there's like some certain step that only like 2 people know, this kind of like wraps that up and you put it into your build process so that it's not a thing where if this person left the company, it's the liability or we don't know how to do that or I don't want to do that because last time I did it blew up because I didn't know the secret stuff. So this also gets rid of that. So that's great, if you're meeting the definition, but as a partial goal, like you can start getting the benefits of doing some of the steps of the process without doing all the steps, and this is just kind of these are the most immediate things that you can gain from your application. Like, not writing autoloaders anymore is pretty awesome. You're going to need to really understand how autoloaders work, but you won't ever have to write them again once you've transitioned your legacy application. Lets you a lot of flexibility to fix prior problems. A lot of things that were like, no, we just can't change that, or we're stuck with this. Gives you some flexibility around that to use stuff as a library instead of like symlinking. Like you can fix things, and it's pretty cool. And everybody wants to use the latest toys, so if you're like, I can't use Composer or I can't use PSR namespaces, well, eventually you can in your application, your current application. So this is an artifact of, I think the whole CI/CD DevOps movement is an artifact of like the Agile movement, but it's not required that your organization subscribe to Agile to be able to do some of these steps. I think Agile is neat, but it's really hard to change your organization. It's much easier to change the software and benefit. So that's the part that I would say to spend your efforts on. Downsides, yes. It's still kind of an epic thing if you want to go end to end and have a fully working CI application. I would say go for the small wins and see how it goes and just keep iterating on it, but it may take a year to get to where you just check in your code and everything flows out to production on the other end. Especially with test suites, if you don't have buy-in on your team about writing tests, that's just not going to change. I don't know, do you guys write a lot of tests or no? Who does write tests on a daily basis? Weekly?
I don't, but my team does.
They write the test for you?
Well, no, we have a QA.
Oh, okay. So does QA write the tests?
He's running Jenkins.
Okay, for CI.
Yeah.
So who writes the test? Just the devs that wrote the feature write the test?
No, he does.
Okay.
Well, I give him the steps, you know.
Mm-hmm.
We don't really use automated testing instead.
Okay.
Yeah.
So, but yeah, anyway, that's downsides, yes, it takes a while, you need to have buy-in. So, places to start, I think the hardest, but the most beneficial is like the whole namespacing and autoloading part of your application. It makes it easier to maintain. If you have an application with a bunch of requires or includes, or you're not using some sort of autoloading, I would say definitely try this out because it will fix it. Is anybody using require versus just PSR and autoloader? Who's using PSR and autoloader in all their projects?
Like new ones?
No. Everything that you have to support.
It's a mix.
It's a mix.
Yeah. Unfavorable mix.
Okay. All right, so anyway, we'll cover all this stuff, except I think that we'll skip the Docker bigger, the DX today. So namespacing, nice to have. You don't need namespace. You can keep using whatever the class names are. It is an optional improvement. You can't cheat around one file per class with the way I'm going to show to get around the old way. I need to check this because it might be that I'm wrong, but I think that you have to have just one class per file to make it work. You definitely can't cheat around having unique names. It's not going to work if you have multiple classes that have the same name across your application. You're just going to have a collision. Only the first one it sees is going to work. But you do not need to fix class name to file name or path name to namespace inconsistencies. You don't have to fix case sensitivity. Like, all that will not matter. It's good if you go ahead and refactor your relevant paths because that's going to make CI a lot easier later. If you have absolute paths on your server, you're going to have a bad time later. So fix those while you're in there. So the actual process of autoloading with PHP, I had to see how it works a couple of times. So when your application starts up, you have your autoloader function that you hopefully register with the application. So that kind of goes into a stack of autoloaders that PHP knows about. And then it starts going through the code. The first time it finds a token that's a class name, it says, okay, I need this class. it has a list of what classes it has already loaded, and it checks that list. If it finds it, it just goes ahead and instantiates it. But if it doesn't have it, then it's like, okay, I've got to go see if I can find someone that can find this class for me. And it will go through all of the things that are registered in the SPL autoloader stack, tries each one until it finds it, or eventually, you know, if it goes through the entire stack and doesn't find it, that's when you get that you require a class that doesn't exist problem. You know, you get a fatal exception or a fatal error. But that's how PHP does it internally. So, as an example of like what an SPL, or you know, an SPL function looks like, we're using just an anonymous function. We're loading it on the stack. We're doing string compare because it's just the quickest way to see if the class begins with like if for this supposed namespace of my class, and then bailing out if it doesn't exist, and then requiring a class. You may want to do other stuff. You might want to do file exists first if it's, you know, you're doing includes. But anyway, you would never actually do this because this would be this is an example of a PSR compliant. You would just tell Composer to get it for you. But this is how, if you had to write one, you would write it. When you push these onto the stack, you can actually push them on either end of the queue. You can tell it to load early, or you can tell it to load late. So if you're writing it for a library that's not going to get called much, you probably want to put it at the end of the stack, because every other class that gets loaded will try your autoloader first to see if yours is going to be the one that services it. And that's not really beneficial if the classes are something that doesn't get loaded often. The other thing is you want to make sure that everything that you do register as an autoloader, you have no overlaps in the namespaces that they service, because if you write one that just says, okay, look for this file and load it, the first one that it finds that will service it, it'll just start loading things, and you'll get the required class that didn't exist. You'll get fatal exceptions. When there was a valid autoloader, but it went to the wrong one in the list. Okay, so you can have the nice, perfect autoloader PSR namespace, unless you have like one of these conditions, in which case you can class map load it and just skip, not worry about ever fixing it. You can just make it into a library. It's great. Let's pause. So what we do, like in this case, this is an example of what we throw in the Composer. In the autoload section, we just tell it class map. We give it a path, and the next time we run Composer, it will go and recursively scan every class that exists in there. Over on the right, I've got an example of like what is actually in the Composer autoload class map that it generates. Those are all the classes. It's just array key values. So it says, I need this class, go get it from this file. So that's why it just doesn't matter about mismatched names and where the files being in the wrong place. It just matters that you have a unique name so it can go find the file. It's really quick because it's already there. You don't have to do any file exists, or you don't have to do any string stuff, because you're looking for an array key, which is like really quick. It's like log n, I think, for the keys. Yeah, it's log n for keys, so it's really fast to get them out. I mean, it still takes time to like actually open the file and load it into memory. But searching it is super fast, even if you have thousands of them. You'd have to have like tens of thousands before it really became a performance problem to look through the array of your classes. Just want to mention the front controller pattern. Hopefully your applications do this. I know in the old days we would write a PHP script, and we would do our require whatever, a header footer in every class, and you had multiple entry points in your application. Hopefully not, so I don't know. They certainly exist. I think even WordPress is still a multiple entry application. Security nightmare, but anyway, once you make the change to, instead of having all the required statements everywhere, I mean, if you have multiple entry points, you're still going to have a lot, but if you had single entry point, you only need the required ones for the vendor boost or the autoload statement in like 2 places. At the beginning of your application, index.php, and then again mentioned in the php.xml, because technically you have 2 applications, they each have an entry point, but they're like separate things. The test suite runs, it's technically an application, and so it has its own version of the autoloader, but they can both use that same Composer. All right, so library management is another area you can modernize an old application. Let's see. So pair is a particularly bad area if you have pair dependencies. It's probably time to write them out because they're so bad. They're not going to get updated. They're just not working. They're calling, like, you're probably seeing all sorts of errors anyway. You probably know if you have pair problems. But it's probably time to write those out anyway. But for other stuff, if you've been using some library in the past, it probably exists as a composer package. It's time to just go delete the one that you copied in manually and instead include it as a composer package and just start trying them one by one. It's much better to just have composer handle all that stuff because then you don't have to even have it in your project anymore. You'll just check in the composer lock and you'll go grab it every time the build runs. I think that's the easiest one to do. It doesn't have any dependency on the other stuff. It's nice to do them together, but you don't need to. You can also create composer packages from your own code. And this is one of the strategies we had to employ when we use a shared services library for all of our stuff to get in and out of persistence and our models that are hidden behind the view. So we packaged up our whole services thing and made it into package. We did this whole thing with the class map because it wasn't PSR compliant. And then we can include it into any of our other applications. We say, okay, well, go get it from here. This is a repository. Instead of registering it on Composer's registry, we just keep it private. And then we tell it, class map everything in, and then every time the application runs, it can find all those files. So, all right, so the next thing is build tools. A lot of people that do PHP, like this is your first language, but I'm finding more in Austin, there's a lot of people that did Java first. I think that's cool. I never did Java, so I was like, what? But we use build tools, and I know it's like a dynamic language, it seems kind of a weird thing, but especially with CI, just to do all the little steps as the code goes out, we don't have to compile, but there's like 50 other little things that have to happen, so we use a build tool. You could bash script everything, or you could even PHP script everything, but there are good reasons to use a build tool instead. One is that bash scripts you can write for one server that work great. You move it to another server, and the client runs it under a different shell, and suddenly your script doesn't work. Whereas the Ant scripts are going to work either way. You can certainly do some of your processes in PHP, and I'll get to that, but I would say do as much as you can in the whatever build tool that you choose to use. I'm going to recommend Ant if it's your first one. Otherwise, go crazy with whatever you like. But CI servers also love to use Ant stuff. It makes it really easy to integrate. These are some of the things we use it for. Obviously, building all those assets for. I'm not a super JavaScript guy, but we definitely have people that are just front end only, and it's like, oh, we have to do 10 minutes of building Ember stuff every time we do a deployment. That all gets scripted in, so I don't have to deal with run this target and build all these little files. Other uses, like SCPing stuff out to production. That's another good target. I don't have to worry about whatever the configuration has to be to deploy my code. I just tell the target to go, and it goes. I do use Ant to bring up virtual machines on my local machine for development and testing. I also use it to make sure that all the services in the box get launched. One of the cool things with Ant is that you can run processes on other servers. Like you can bring the box up and then tell it to run other processes in that box on the remote machine from your machine. So it's pretty cool to be like, okay, bring that box up and start MySQL, and then insert these 2,500 records or something. And then, yes, launching tests is one of the last steps in our CI process. So, and it's an XML based, which makes it really verbose, kind of a pain to code for if you're used to JSON, I guess. It does have conditional logic. I think you have to patch it to get conditional, but you can definitely do if, this, else, whatever. It does support variables. They call them build properties. Targets can call their targets. They're remote or local, plays nice with CI. So this is a sample like of what the XML would look like. This just has one target. All it does is call PHP unit, but this would be typical of like the kind of stuff you would do, or I would do. I've got, prior to calling this, I would of course call composer, like a composer step that jumps out, calls composer, installs PHP unit from the composer.json, and then when we get to here, it will call PHP unit, and then we're passing a couple of command line arguments. We're saying log the output to standard error, and then tap, which is the test anything protocol, which you've never run tests with tap. It's really cool, especially on the build server. You see the tests in real time, and it tells you, I ran this test, it passed. I ran this test, it passed. So if you're looking at a running build and it's failing, you can know immediately what test it was that failed without having to wait for the entire test suite to finish and look at the results. You'll know right away that, oh, test 27, which is blah, 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 is the one that's breaking the build. You can stop it and go fix it. All right, mixing PHP and build tools. So one of the weird things, because you're probably, if you do this, you're gonna mix something with PHP, some things in Ant. The weird thing with, it's not weird, I mean, it's been around for 40 years. Return codes of Unix shell commands, they return 0 if they succeeded, whereas PHP, and we test a function or something, we're expecting it to return essentially 1 loosely, or something that's not 0. So they're kind of flipped. So when you're writing scripts in PHP and you're going to return to Ant to let it know that it succeeded, you just want to do an exit call. Technically, if you don't pass anything, it does call. It calls exit 0, but I'm just being explicit. And if you call exit 0, it says, my script succeeded, but if you had an error, you can either call exit anything else, or you can throw an exception, which also counts as a return code other than 0. All right, so what happens on the continuous integration server? Usually for in CI, you're going to say, okay, check out my code, build it, do any pre-processing stuff. I left out the deployment step, and then call the test, look and see if the test actually passed. And then along the way, make sure that every single step succeeded as well, or it will fail to build. So if it wasn't able to check it out, it'll fail. Anything else. It's really frustrating the first time you set up a CI target because it's like everything breaks. But once it gets going, everything just runs every single time. And then the last thing is, yes, once the build's complete, it kind of radiates that information to your team, which is a kind of a people and cultural change, but it is part of the job of the CI server is to like tell everybody, yes, your builds succeeded or didn't succeed. Go fix your code. So of the ones I've used Travis CI for some small projects to try it out. This one integrates really well with GitHub. It's only like 3 lines of configuration if you want to try it out. And I have like a lab recommendation to try it out. But you can get started with Travis CI and like, you can write a brand new project, just write a couple tests, and go crazy and have it working in 2 hours for the whole project development and get your little badge that your build is passing. I think it's kind of pricey. I think they have good documentation, but I do think it's pricey, but I think the barrier to entry is really low, especially if you're just doing a little project, it's free, so you can go try it out. I used Jenkins and Hudson for about a year, and that is like you download it, they call it a WAR, it's just a Java file that runs locally, you have to host it yourself. It's a little more, well, it's a lot more complicated to get set up, but it does have by far the most information to go find out about it. It's community supported, so it's hideously ugly in the UI, but it does work. We use Bamboo. We use a lot of Bamboo. That's an Atlassian product. It's not terrible. It goes down occasionally. One of the things I find with Atlassian products is if you're hosting it yourself, it's going to go down once a day. If you're hosting it on their cloud, it might only be every 2 weeks, but it's going to go down. So we're obviously using hosted everything now because I was like, I do not want to keep kicking servers up all the time.
We stopped using Bamboo when it earned the nickname the Bamboozler.
We're going down? Yes. Oh, okay. I've never heard that before. That's funny. It does, the integration is phenomenal across their tools. So if you're already doing Jira, which I think is the most expensive part of the equation, I I would say then definitely do Bamboo. HipChat, yeah, works great. Like, you can have it throw messages in as your builds succeed or fail. Stash is the equivalent of like your GitHub where you keep the code. Those two work together pretty well. Bitbucket is their web version of Stash, where it's just their version of GitHub. They didn't want to lose all the pie, so they have a version that, to check code out, and then like Jira. So it's pretty neat because you can watch an issue, you can see the builds in your Jira tickets. Sorry, their issues, whether they were passing or failing. You can comment on them. You can also see branches and things like that, which is pretty neat. We do feature branching, so if we have a story, we'll go feature branch it. As soon as that branch appears, like it moves the issue on the Jira board into in progress. And then when we open a pull request, it says, oh, it's done, so it moves it into in review, and so our QA person knows to go check it out. And then if it gets merged, it moves the ticket to done, so I never have to go into Jira and actually update ticket status. So that's great, but try something else. And then Teamcity, I'm mentioning it, I've never used it, but everybody likes JetBrains stuff for the product. So they have a product, I think it's you host it, but I have not used it.
So I know TeamCity. So it's free if you don't mind everyone in the whole world seeing your stuff. Otherwise, it's like it's cheaper than Bamboo, Jira, and all that stuff. A little bit.
Yeah, I think Travis CI is free, like unlimited in that same way.
If
okay
it's
with everyone
public.
seeing it. So if you're doing an open source project, go crazy, but
Yeah.
if it's your company code, no, probably don't.
And Travis CI gets expensive quick, as you noted up there.
Yeah, I think it was like you get one thread, and if you need more, the models are all weird. I mean, yeah.
There's a couple other ones. CodeShip, I think, is one.
Circle CI.
Circle CI.
I love that one.
Yeah, I've never worked with those ones, so I'll check them out.
And then like back towards like the not CI servers but deployment tools. I don't know if you've worked with deployer.org, robo.li, DeepL.io,
We
Rocketeer. That's
we
the
use
other one.
so we have HipChat, and then HipChat has robots that you can get from Atlassian Standard.
Yeah,
We use those robots to do
to like deploy from.
Yeah. So like when I'm in chat, like I can be on the bus or whatever, and I can be like, oh, it's time to deploy this, or it's approved. I just get on my phone, I type deploy, blah blah. It sends me an email with an authorization code, and I go back and I'm like deploy blah blah. Here's my hash, and the code goes out. So it's pretty neat. We do a lot of stuff. We do too much stuff with the robot. Like you can ask it what's for lunch, and it'll tell you what's for lunch. There's a little RPG that we play. Anyway, there's about 50 little things that we do with that. We push, so schema changes, which is the thing I didn't talk about, but that is another thing that we control through CI. And well, with source code control, so we have a repository that is just for schema changes. We'll check those in to a target that goes to for development or development instance, and then we can promote it to the next server, and then it goes out to deployment, but it's all done through the robot. You can be like, send this thing out, and it will go make the schema change out of production.
And it works with Slack too, right? Like I think they have similar.
I think it does.
hooks.
They ported the robot to Slack. And I was kind of like, I'm only doing one text thing at a time, so I didn't jump on, but yeah. So, okay, post deploy hooks, these are like special case things that you have to do. These are concepts, how you implement them are going to be different, but they're things that you probably eventually will need to do to make your CI process work. One of the steps that we do in pre-deployment is we run Composer and we run all the Css asset building because we don't need to do it twice. When code checks out, it checks out on the server that runs the build, the Bamboo server. That's not the code it's not where the code is going to be hosted and tested. So, but anyway, we check it out into a workspace. We run all of the pre-build stuff. This is why the relative path is important. Builds everything, and then it rsyncs it all out to the server after it's built. So we only do it once because it may take 10 minutes to run Composer and all the other stuff. And then rsyncing only takes a few seconds because you're just doing the diff. So that's a pre-deployment thing. Would be like running Composer, building all the CSS stuff. The DB credentials also get injected there because if we're creating mocks and storing them in the database for the tests, those same mocks need to be in the same database when the web server looks for them on the other side. So we'll like build a customer account, build a statement, add a bunch of things to it, and then when the web server comes up and tries to display that, it needs to be the one that we just injected on a different server. So we have multiple servers pointing at the same database instance, and we refresh it like every day for our testing environments. Deploys the actual copy, and then post-deploy. That can just be whatever specific stuff you need to do. In this case, like kicking Apache. We have some projects that just do internal stuff. So a page request might take 4 hours, where it's running a report or something like that. Obviously, don't write your web pages like that. But if they just need a report, that's what they'll do. But if you're going to deploy code, you go ahead and just tell Apache to restart and stop doing that. Maybe restart Memcache, that kind of stuff. Or if you're doing a site like Magento project, you may want to start running your cache preheating scripts that start building up those cache before you get real requests. You guys ever worked with Magento? 8 levels of hell? Okay. And then after all these things are done, it'll run through the actual test suite, running the code, looking for the results, and then disseminating that information to your team. So if you wanted to get started with this, this is what I did to try out the CI. But yeah, just do something where it's controlled and you can just change all the variables. Don't try to do it on your project first. But just make a new project, anything useful, just do a couple tests, get all that working, write a build script, package it up, and then push it off, and then get it to pass. Like that's the second half is probably like half the project of going through, reading the documentation. But that'll teach you the concepts you can take back to your own application and be like, okay, I know how to fix this, I can make this better in your application. So that is in a nutshell, the road to CI. I'm sorry my slides are a little